Okay, in health areas, just to show you how work happens, 2 professors from Yale University came to us and they said, we think we've got a better way of understanding whether cancer has returned to a body in the bloodstream. We think there should be occasional cancer cells, but they're only 1 in a billion. Can you help us figure out the optical system, the counting system, the measurement system, the resolution, to see if that's possible to do? And it took about 10 years. And we worked with a guy from PerkinElmer in the optics, but he got so excited he left PerkinElmer and joined the company we'd created. So this just got commercialized. We have about 160 people work at the Centers for Disease Control in Atlanta. So we design the US flu vaccine every year. We work on Ebola, Zika, and I'll show you a picture of our Ebola work in a moment. This is a really nice story. So premature babies have a real hard time breathing, and they need to have a drug that the body normally generates in the lungs. But if they're 24 to 26 weeks, they can't generate it. So you have to stick a tube down their throat to get the drug in, a surfactant. And that can cause major damage to a premature baby. So this is where the worlds of chemical dispersion and medicine come together. So it turns out we're really good at aerosolization. So we started working on this problem, and we've just commercialized units where the baby can have a mask and the surfactant can be inhaled naturally, effectively into the lungs. So the drug was pre-approved by the Federal Drug Agency, but the methodology had to be approved. We've just done that. This is Ian. Ian was a good lacrosse player, sort of healthy, athletic guy, 23 years old. He dove into the ocean, hit a sandbank, came up, paralyzed from the neck down. He's a great kid, but he's paralyzed forever. But he was willing to work with us, and we'd been trying to figure out how to decode a brain signal. So if I ask you to raise your right hand, your brain is saying, raise your right hand. Signals are being generated in your brain, and your hand responds. That's how the brain sends messages. And the muscles react to the brain stimulus. So we got really interested in decoding brain signals, and how would you convert those to action? So what we did was we built a sleeve that has actuators on it that respond to the brain waves, and we put a chip in Ian's brain. Now, believe you me, we didn't. A very good brain surgeon at the Ohio State University did. We supplied the control systems, the electrical engineering, the computing, and everything else. He put the chip in. So it's a very emotional, you can look this up. It was called NeuroBridge at the time. It's now called NeuroLife. Ian is sitting there, and we're sitting with his father, and with our researcher, and with Dr. Ali Razai, the surgeon. And for the first time ever, he thinks, I want to raise 2 fingers, and he raises 2 fingers. Last week, he was able to slide a credit card through a device, and he can play a guitar. And that was all over the US news this morning. Yeah. So I think neuroscience is a really intriguing place to be. And the materials question here and the engineering questions are really profound. So the electrical signal understanding, the decoding of signals, the control systems, it's a very engineering-oriented business. And then you've got the question of how long does a chip safely survive in a brain? It's a materials problem. So everything I look at, I see materials, I see engineering being the solution space that you have to get into. And they're very broad: energy, national security, and so on. I've talked about all these. Oh, Ebola. So here's a funny story. So we've done a lot of work on Ebola, developing vaccines, helping people. We had people in country. And the president decided he wanted to have a good news conference about it. So the two scientists from Battelle, who had been instrumental in doing all the work, were asked to go to the White House. Can you tell which two they are? Yeah. They got lab coats on. Lab coats in Ebola are not effective. So they show up at the White House for a 3 o'clock meeting or 1 o'clock. And the people running the meeting say, no, you're a scientist. You can't wear a suit. And they said, no, that's how we dress. And they said, no, you've got to have a lab coat. And they said, no, it's ridiculous. You don't wear lab coats for Ebola. They said, no, you absolutely got to have a lab coat. Come back in an hour with lab coats. So they're at the White House, and they go into D.C., and they don't know where to buy a lab coat. But it's Halloween. It's Halloween. So they go to a Halloween store, and they sell lab coats, because people like to dress up as doctors. So they go back to the White House with the lab coats, and the people there say, well, that's great, but they need to be ironed, to be pressed. Something else scientists never do. So anyway, there they are. This is their moment of glory. They're not looking too happy about it, because I think they know they're going to get a lot of ragging about this, a lot of ribbing about wearing a lab coat. Anyway, these are some of the more real pictures. Agriculture. We do a lot of work on plant metabolism, trying to speed up growth. A lot of work on alternative fuels, in particular biofuels, which we're very intrigued by the work going on here. Bioformulation to get various processes approved. I'll mention this one, probabilistic risk analysis. We call it PRIA. So this has to do with something very simple. People farm chickens, they slaughter the chickens, they clean the chickens, and then they ship the chickens. And what you don't want to have happen is salmonella, which is a dangerous disease associated with poultry. So we had a young lady who was working on Homeland Security on deliberate food poisoning, and how that might be prevented, understood, and so on. And she got interested in this process, and she wrote a piece of software that's become more and more sophisticated, where you ask, where was the animal slaughtered? How was it cleaned? What were the strengths of the chemicals? How far is it being shipped? What's the likelihood that the shipper is going to keep the temperature right? And when he gets to the end and is bought, what's the socio-economic standing of the community that buys it? And you can add all of that up and put a probability that there's a risk associated with salmonella against it. And that software is, there's a gentleman here from Australia earlier today. And anyway, about half of the Australian chicken distribution system now uses this. And we've now started using it in other commercial enterprises for food. And then finally, a couple of others. We do food packaging, Oreos packaging. And people are always looking for interesting ways to make packaging easier to close and open and reseal. But I'll move on here because I want to come to a little bit of national security. Liquid bottle screener. So when you go to the airport and you've got a bottle, you can't take it in. So in Europe, they had all of these expensive whiskeys and drinks, and people don't buy them because they want to be able to physically carry them on the plane. They don't want to put them in a bag and maybe it gets delivered. Then they feel guilty when they did buy them. And it could be a woman buying perfume or a man buying expensive whiskey, but then they'd buy something for their partner. And that whole economy crashed when they stopped allowing you to take bottles on the plane. So there was a requirement by the European Federal Aviation to design a bottle screener that you could just put a bottle on, and in 3 seconds, it would say yes or no. So either a green light goes on, and you pick it up and go through, or a red light goes on, and you're having a conversation. So we designed one, and ours works with glass, or with cans, or with plastic. So there's ultrasonic, millimeter waves. It's got a barcode reader on it. And it's been at Heathrow and some other airports. So we do a lot of work on airport security. We stress the security systems at every one of the United States airports. We send teams in to test. We develop a lot of the software. How many of you have had to do a screener? If you're doing this with an L3, that's a Battelle invention, is the L3. The other one is called Rapiscan. That uses X-rays. We don't like that because the X-rays could be damaging. L3 uses millimeter waves. You don't have a choice. They're either one or the other. But they're getting rid of the Rapiscans and replacing them with L3. Biodetection. We manufacture the primary biodetection systems for the United States. Every time there's a Super Bowl, State of the Union, key buildings, there are devices there that right now suck air 24/7, 365 days a year, looking for one of 18 known pathogens. We've replaced that with a more sophisticated machine that uses Raman spectroscopy and detects anything that shouldn't be there. This guy on the bottom left is called Bluefin. This is an underwater autonomous vehicle. This was the thing that was used to try and find the downed Malaysian aircraft. Paul Allen of Microsoft owns one on his yacht. He likes to discover downed airplanes from World War II. And then we just sold this company. It got to a point where we will manufacture things, but if it gets to be a lot, we're not that good at that. So at some point, we'll hand it off or license it or sell the company. So we just sold this guy. And then we also make armored vehicles. These are usually Toyota pickup trucks from Europe. And they come to us weighing 2,800 pounds. They leave weighing 8,500. The armor is about 3 inches thick. They have multiple batteries, multiple electrical systems. The glass windows are about 3 inches thick. We had to design a new way to raise and lower the windows. They're so heavy. They have very interesting headlamps that allow you to see in the dark. And they go off to places where the US troops are in danger. So these orders are at about 100 a time, so we can handle that. So that's the kind of thing we do on national security. Non-proliferation, we're very heavily involved in non-proliferation, understanding what countries are trying to get access to uranium, plutonium, and other things that are bad. These are the countries that have nuclear weapons. If you're good at flags, you can figure it out. If you're not, I can explain it. These are the countries that have given up nuclear weapons. President Kennedy predicted within 10 years of his famous speech there'd be 25 countries with nuclear weapons. There aren't. There's only these 10. And, 11, I guess. But part of that has been a result of treaties. And part of it has been the difficulty of really manufacturing weapons. But this is something we're very expert at places like Oak Ridge and Livermore and Pacific Northwest.